Hi Year 12s! This is a video to reintroduce the algebraic concepts regarding polynomials. A polynomial is any function that has multiple terms, where the x's are to the power of a positive integer. So, for example, these are all examples of polynomials. This is because all of the x values are to a positive power. As such, these are not polynomials. For those of you who really want to know what's going on, here is the technical definition of a polynomial. But if you don't understand what that notation means, don't worry, it's not essential. However, it is important to learn how to solve polynomials algebraically in order to help graph them. There are different types of polynomials. Here, we will explain two different types of polynomials and how to solve them. Our first type is second-order polynomials. When n is equal to 2, we have a second-order polynomial, which is also known as a quadratic, a term you're probably more familiar with. The general formula is f of x equals ax squared plus bx plus c. A quadratic is unique because when finding the solutions, we can simply use the quadratic formula, which is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. This allows us to determine the solutions, but it can also be used to check if there are any solutions in the first place. If b squared minus 4ac is greater than 0, there are two solutions found through the equation above. If b squared minus 4ac equals 0, there is only one solution, and it will be x equals negative b over 2a. If b squared minus 4ac is less than 0, there are no solutions, as we cannot have the square root of a negative number. The turning point can also be easily determined, as its x-coordinate is the midpoint of the two x-intercepts. If there are no intercepts, then it can be determined through the formula x equals negative b over 2a. Our next order of polynomials is third-order polynomials. When n is equal to 3, we have a third-order polynomial, more commonly referred to as a cubic. The general formula is f of x equals ax cubed plus bx squared plus cx plus d. In order to solve cubics and higher-order polynomials, it is important to group all the terms on one side and equate the function to 0. Then, we need to use trial and error to factorise the equation and find the solutions. We start by guessing a value for x, and then seeing if this value equates the function to 0. Let's look at an example. Question 2 from the 2013 Exam 2. If x plus a is a factor of 7x cubed plus 9x squared minus 5ax, where a is a real number that is not 0, then what is the value of a? Sometimes, we would need to group all the terms on one side, equating the function to 0, and use trial and error to find our answer, by subbing in values and seeing if that function equals 0. However, as we can tell just by looking at this equation that x is a factor, that is not necessary. So we remove x to the power of 1 from all three terms. Remember, our indice laws tell us that dividing by x is the same as subtracting 1 from all x powers. So x cubed becomes x squared becomes x, and x becomes x to the power of 0. Therefore, we go from this to this. While this may seem counterintuitive, the question tells us that x plus a is a factor, so we know that we can take that out of our equation. But then, we need to figure out what goes in the other bracket. We know the first term of our final factor has to be 7x, in order to get the 7x squared term. And the second term has to be negative 5, in order to get the negative 5a term in our original equation. So taking out x plus a from our simplified function gives us x plus a times 7x minus 5. Now this is confusing. If you expand this, you get 7x squared minus 5x plus 7ax minus 5a. This is not our original function. But remember, our goal is to find a. And because the question tells us that x plus a is a factor, we know that our new function must equal our simplified function from earlier. Therefore, minus 5x plus 7ax must equal 9x. Now, we just need to simplify this equation to find a. Using simple algebra, we can see that a equals 2. Don't worry if that was confusing. It's nothing a bit of practice can't fix. Let's look at another example. Here, we need to express x to the power of 4 minus 8x in the form shown. Here, we need to perform some manipulation of a fourth-order polynomial. Our first step is fairly straightforward. As we did above, we start by taking x out of the equation. Now we need to find another factor, and a bit of inspection will lead us to realise that x minus 2 is a factor of the equation. We know this because if we sub in 2 to the equation, it will equal 0. Using the same logic as in the previous example, we are able to devise the first and last term of our second bracket. Since the first term has to equal x cubed when multiplied by x, it must be x squared. Since the last term has to equal negative 8 when multiplied by negative 2, it must be 4. From our question, we know that the b term has to be such that when the function is expanded, there is no x squared or x term. Therefore, minus 2bx plus 4x equals 0, so b equals 2. So x times x minus 2 times x squared plus 2x plus 4 is what we end up with. Now to do the last step, we need to make up an x squared term, which we can see can easily be x plus 1 all squared. This will then take 1 off our final number to give our c value a value of 3. Happy studying!